Okay, so today we're going to go over the absolute value inequality. And an absolute value inequality that we'll be looking at will be in terms of a linear expression that's having the absolute value taken of, and it will be less than some number c. So we have ax plus b. What does this mean? Well, this is really two different expressions. One, we're saying that ax plus b is less than c. The expression ax plus b is positive. However, negative ax plus b must also be less than c. This is how the absolute value works. So what we do now is we're going to take a look at the second expression, and we're going to multiply both sides by -1. And you get ax plus b is greater than negative c. Note something very important here. When we multiplied both sides by a negative number, the inequality sign that you see here flipped. So anytime you multiply or divide by a negative number, the inequality sign will flip. So let's re-express this down here. We have our negative c is less than ax plus b, which is also less than positive c. What does this look like? It's a three-part inequality. Just as we did before, we've got a negative c and a positive c on our number line. This is a number line of all real numbers. And our expression ax plus b must be in between negative c and positive c. And so note one thing that's very important here. What's in the very middle of negative c and c? It's 0. So you can think of this absolute value as the distance from 0 cannot be more than c. When we come back over here, we just set up our tree like you normally would for a three-part inequality, and that's just ax plus b is greater than negative c, and then ax plus b is less than positive c. And then you just subtract b from both sides and divide by a. You get negative c minus b, all divided by a. And then on the other side of the expression, you get x must be less than c minus b divided by a. Now let's do an example. Here we have x plus 2 is less than 3. So we're going to set up our little tree here. On the left-hand side, we have x plus 2 must be greater than negative 3. And then on the right-hand side, we have x plus 2 must be less than 3. Alright, and then we're going to work both sides, and we find that on the left-hand branch, we see that x must be greater than negative 5, because that's what happens when we subtract 2 from both sides. And then on the right-hand branch, when we subtract 2 from both sides, we find that we have x must be less than positive 1. And so let's look at this on the number line. Got our number line. We're going from 1, and it's got to be greater than 5. And so we're in between here. Now, if you notice, the number that is precisely midway between these two numbers is negative 2. And so whenever you see an expression that looks like the one we have here, you will not be able to exceed 3 units away from negative 2. Because you can see right here, you can go to the right 3 units, or you can go to the left 3 units, but you cannot go more than 3 units. Now for our next example, we have x minus 1 must be equal to or greater than 2. And we do this one the same way as before. We notice that we have not a strict inequality anymore, and now the inequality sign is facing the other direction. And so let's see how this works out. We can look at the left-hand side, still the same procedure. We have x minus 1, flip the sign, and make that negative 2. And then on the right-hand side, we go x minus 1 is equal to or greater than 2, just as it was before, just without the absolute value. Now we just add 1 to both sides, and we have x must be equal to or less than negative 1. and then x must be equal to or greater than 3. Alright, so let's take a look at this on the number line. Starting at -1, fill in the circle to show that we're including it, and you note we go to the left. And over here the same thing. We fill it in and we go to the right. We're moving away. And so we've created, you can kind of see, think of this as a forbidden zone right here. X can be everywhere, but it cannot be in this blue area I've highlighted here. And let's note something about this highlighted area. It's centered right here at the point x equals 1. And this forbidden zone extends in 2 units in either direction. Report this answer in interval notation as x equals -infinity to -1 union 3 to infinity. And since I got the interval notation for the second one, let's go ahead and get it for the first one. This one is simply x equals -5 to 1.